Okay, so I'll turn this around so you can see that. I'm just going to do just a quick list of a couple of terms that I just take for granted people understand and know. So some of the things that CryptoKitties depends on. So Ethereum is a public blockchain. It's a blockchain that differs from the Bitcoin blockchain in that it's designed to execute code. And the code that you deploy to Ethereum are called smart contracts. And to run a smart contract, you need a fee. And that fee is Ether. Ether is the native currency on Ethereum. And the other thing you need at any time you interact with a blockchain is a wallet. And a wallet kind of is a mechanism that holds your keys and allows you to create transactions that you can send to a blockchain. In this example, I'm going to show you MetaMask. And the last thing is an Explorer. There are kind of software out there that lets you kind of navigate your way through a blockchain, and Etherscan is something that we use when we want to look at Ethereum. So moving quickly on, here's the definition of what CryptoKitties is from the people who made it. So it's these digital collectible cats built on the Ethereum blockchain. They can be bought and sold using Ether and bred to create new cats in exciting new traits and varying levels of cuteness. So what it is really is sort of kind of two things. It's a marketplace for digital assets and a bit of a game around sort of creating these new cats. We kind of used it because most of the applications you see in Ethereum, are based around payments or around currencies. And this was the first that kind of was quite fun and interesting. But actually, there's some really, really good sort of theory practices behind it. So it's a nice one to use just to demonstrate some of the things that go on with blockchain. I took a few screenshots because I wasn't going to rely on network because that was always going to fail. So this is the kind of my home screen for CryptoKitties. And to use the game, so it's a web application. And if you look at the top right, you'll see the MetaMask wallet. So they said this is an Ethereum wallet that runs in your browser. So it lets you basically load up some private keys, load up some Ether, and interact with Ethereum. And you kind of need that to use the game because, as I said, the game relies on Ethereum. So certain things that you do on the website will interact directly with Ethereum, and then you've got to pay a fee for that. So you need the wallet. And I have my three cats. I have Pip and Bear, I have Peaches and Cream, and Killer, who is the daughter of Peaches and Cream and Pip Bear. So that's my three cats. There is a marketplace. So the idea was when they first released the game was they have smart contracts and they generate these kittens every about 15 minutes or so. And that's going to happen until the end of next month. It's November 2018. That ends. And they did that just to kind of, create cats and get people going, push some liquidity into the market if you want. And you can buy them for as little, probably about 30 yen. Will buy you a CryptoKitty. But last month, I think at Consensus, somebody bought a cat called Dragon, and they paid 170,000 US dollars for it. So obviously, something very special about Dragon. Go figure. And you can breed them. So this is kind of the game part of it. So the idea is the cats all have unique traits, and there's algorithms that when two cats with different traits get friendly, they create other cats with different traits. And the idea is certain traits are more valuable than others, which makes the offspring, the new cats, more valuable than others. And so in theory, you can sell them for more money. So that's kind of the game part of it that they added in. So. And then the last thing is you can sort of get this activity list of things you do. But the interesting thing is, from a UI, it's quite a simplistic sort of application if you want. But there's just lots of really interesting things going on underneath all of that. So for example, if you take that top transaction here, this was me breeding my new cat. And from a UI, it doesn't look very special, but I can actually go underneath all of that. And that's the transaction on the Ethereum network for that breeding. I said there's a smart contract that manages all of that. And you can see, obviously there's a lot of information there, but you can see, that cost me $5.50 roughly to do it. And when I sent it to that contract, it split the money and sent it on somewhere else. And I'm pretty sure some of it went to the owner of the cat that got friendly with my cat, and some of it went to the CryptoKitties guys, because I guess that's how they monetize the game. So it's quite interesting because you can kind of lift the lid on this application and see what's going on underneath it. And I said there's some pretty interesting things happening. I kind of tried to summarize their application architecture at a high level. It's a bit more detailed than this, but this kind of captures the main parts of it. And I want to show it because it's actually really well laid out from an architecture perspective. They've done a good job in splitting out the contracts. And so we've got like a web app in yellow, and all these red boxes are smart contracts that run on the Ethereum network. If you're interested in smart contract development, or you're interested in Solidity as a language that they use, you should take some time and go look at those contracts. They're very well written, and from a design perspective, they've kind of tackled a few of the issues you have with Ethereum, and they've done it very well. So they open sourced nearly all the contracts, so you can get those on GitHub, and they're worth a look if you're interested in that kind of thing. But going right from left, they have a nice pattern in that the Kitty base, just bottom right on the far side, that's like their data store. It's a little repository pattern. So all that contract cares about is the cats. So it stores the cats, it's got getters and setters for the cats, and it knows who owns them, and it allows you to transfer them. It doesn't really know much about the game, it's just all about the data store for the cats. And then what they did is they then wrapped that contract in another contract. That Kitty ownership implements the ERC721 interface. I'm going to talk about that in a later slide, but it was nice that they kind of split their implementation from their interface, so it's a nice pattern. In the middle, kind of all the features of the game are deployed as separate contracts, and then they're utilized by Kitty Core. So Kitty Core is the main contract that drives the game, and it's the one that the web application talks to primarily. And some of the really neat things they managed to crack. So when you think about, I don't know if anyone's done smart contract development, but the first problem you're going to get that you really need to think about is how are you going to manage code that you deploy to a platform that's immutable. You can't change it. So once you deploy it, it's there. And so how do you manage change, or God forbid, how do you deal with a bug if you've deployed something that's not working? And what they did is that while the code, the contracts you deploy to Ethereum are immutable, the contracts have access to state, and state is mutable on a blockchain. You can't change that, on Ethereum. So if a contract has a dependency on another contract, the address of the contract is held in state within the contract. So again, I'm not sure how much you're familiar with this. When I deploy a contract in Ethereum, it gets deployed and created at an address on the network. So you call that address, and there's like sort of a method call for that in Ethereum. So each contract with a dependency has some state that says where that address lives on the network, and it calls it. What they then did was they put setters on those contracts to allow them to change those addresses. So when you think about it, what they got, their release process now is, so if they wanted to change gene science, they could take it out of Git, update it, and deploy a new version of gene science onto the Ethereum network. That would actually live at a new address on the network. They could then go in to the dependent smart contracts and update the addresses on the contracts to repoint them to the new version. So very, very neat the way they did it. And the other thing they did, which is really neat as well, was you obviously didn't want anyone doing that. You don't want people going in and just, I think I'll change that address, because that would just cause chaos. So they locked it down so that within the contracts there's defined roles. So within their contracts there's a role called CEO and CFO. And those two roles are the only people who are allowed to change the addresses within the contracts. And those roles really, in effect, they map back to addresses. That's how they're represented on the network. And those addresses are really associated with private keys. So where they got to on implementation is the transactions that set those must be signed by the private key of the CEO or the CFO of Axiom Zen, who created CryptoKitties. So they've got a really nice security model and pattern for updating their contracts and managing change with that application. So as I said, and it's really nice, and they took advantage of the fact that you get all of that with a blockchain. That security mechanisms kind of come out of the box. So it's kind of using what you get. One of the good things about blockchain. So we'll move on. I kind of want to go through. There were some things that happened when this game kind of came and got deployed. So kind of on the good side, it was like Well, they use the Ethereum network. So the first time a game is being deployed to Ethereum, you have around about 20,000 nodes, and all of those nodes can process transactions. So you get redundancy. You get very good redundancy using that network. The way they did it as well, rather than an application, they really in effect built a platform, because you can, like I said, you can avoid the web app if you want. You can call those contracts. You kind of usually not the difficulty, but it's knowing how to find them. And if you've got sort of the wherefore, it's not that difficult to call them, and it's quite interesting. You can call all of the contracts and see what's going on. But the thing they did as well, they gamified some of the contracts outside of the web application. So there's a function inside the smart contracts to birth a new cat. So if people are creating cats and sort of breeding cats, there's a life cycle to that of cats get friendly, cat gets pregnant, sometime later, cat has kitten. And the cat has kitten piece was opened up on their contracts, and they were encouraging people to call that because they put a reward on it. So it meant, in effect, they almost created like a little mining pool for cats. They wanted other people to start contributing to the platform and kind of develop an ecosystem. So it was a nice way of doing it, because if you knew where to do the call, and it almost became a game, because people were now trying to search the contracts to find cats that were ready to be born and calling that to get a reward. So it was neat the way they did that. The other good things about it is, like, those cats belong to you or me, whoever, they're your cats. So Axiom's End don't own those cats. So outside of the game, if I can go into my wallet, I see my cats because they're represented as digital tokens on the Ethereum network. They're associated with my private key that's in that MetaMask wallet. So they're mine. No one can mess with them. No one can do anything with them. Axiom's End, who own the game, can't do anything with them. They don't own them. And that's one of the real value adds of a blockchain. And then the security side of it. They can't touch them, they can't update them, they can't do anything with them, because the only person that can is the one who has his private key. And that's all stuff that you get with a blockchain out of the box. Some of the bad things, just to balance everything up, it nearly broke the Ethereum network. So when it went live last year, it kind of went viral. And at one point, 20% of all transactions on Ethereum were CryptoKitty. And Ethereum has a fairly low bandwidth. We're going to talk about that bit later on. But what happened was you got traffic congestion. So the economics of the public blockchains, both Bitcoin and Ethereum, are based on mining, and the miners mine transactions based on fees. And when the transaction volume went up, and then there was congestion, because miners can only get through so many transactions at a time, that everything slowed down. And two things happened. In the game, they had to raise the fees on the birthing, because miners will take transactions with higher fees. That's just the economics of the blockchain on the public side. So the game had to raise the fees, which meant it got more expensive to interact with the game to get your cats through, because you had to pay more. And then really, everyone's on the shared blockchain, so other people who use Ethereum were in the same situation. They had to increase their fees to get their transactions through. So everything got more expensive on Ethereum for a while the traffic load was very high and you congestion. Because again, the miners will always take transactions with higher fees. And then, probably unrelated, but happened at the same time, last year we had the spike in cryptocurrencies. So Ethereum rocketed to $700, $800, $900. And suddenly, your cat that was on sale for 0.001 Ethereum suddenly was no longer 40 yen. It was more like 120, 200, 300 yen. And so things got more expensive on the chain. Now, if you're a hodler or a crypto investor, obviously price going up is great. That's what you're in for. But if you're actually trying to use the network the way it was intended, as a compute on a runtime, that's not good. And you can see the economics of those blockchains get very heavily influenced by the price of the currency on the chain. So if Ethereum went up, then transactions come down, because people don't transact as much because it's too expensive. And sort of the last thing I'd say, where we're trying to finish with, CryptoKitties highlighted the bottleneck and the scalability issues that exist in the current version of Ethereum. It can't do more than 15 TPS, and that's a fairly low number. And so there are probably about 3 big ticket items happening over the next couple of years with Ethereum to get more bandwidth and more capacity out of it. 2 of them are at the network level, around sharding and around Casper, and there's one which is more a change in how they use Ethereum. So it's a set sort of a standard and a set of contracts to basically get traffic off the main network and offload it, and that's Plasma. So with sharding, I mean, I guess from the early days of blockchain, one of the key tenets was transparency was guaranteed because every node had all the data. It had all the copy of every data item, and all transactions went to all nodes. That's kind of a bandwidth issue. You know, when you 20,000 nodes all executing the same transaction, which on Ethereum means executing the same smart contract 20,000 times, it's kind of obvious that's just not going to scale. So with sharding, what they're going to do is break Ethereum into these little shards of blockchains across the whole network, and nodes will be responsible for the consensus with that shard. So it kind of breaks it up so the whole network suddenly now doesn't have to process every transaction. Now, some people may agree, disagree with that as an approach, but you're starting to see that every transaction going to every node is just not a scalable solution for most, particularly when not every node really has an interest in every transaction. On the Casper, so both Bitcoin and Ethereum use proof of work. It's deliberately computationally heavy. It protects the network from a 51% attack. But again, it has scalability issues because it's very high on compute. Because you're trying to, the miners are trying to solve a cryptographic puzzle, and so it's very heavy. So a lot of the newer blockchains, what Ethereum is looking at is proof of stake. It's a much lighter consensus algorithm that, in theory, gives you the same level of protection that proof of work gives you. So there's a move to that, again, to kind of reduce the compute, reduce the bandwidth on the network. And Casper is the first iteration of that. It's a bit of a hybrid, so it's kind of proof of work with proof of stake. And the idea is, over the next couple of years, you'll see Ethereum start to gradually move less from proof of work and more, and eventually to a pure proof of stake consensus algorithm. And they've actually built in a time bomb. I found this out yesterday. Just finishing off this, I was just Googling, and they've built in, there's a thing called the Ethereum Ice Age that's coming in a couple of years. So proof of work mining is determined by a difficulty factor on the network. And so it kind of aligns the network to make it harder or easier to mine. And the way they're going to make sure everyone moves to proof of stake, in a couple of years that factor is going to go up really high. And it's going to freeze the network for anyone trying to do proof of work. So if you're mining and you think you're going to stay in proof of work, you're going to get frozen out in a couple of years. And it's going to force all the mining pools to proof of stake. So it's an interesting approach. The last piece I was going to do was where we started, so ERC 721. It's worth, before we talk about it, is to talk about ERC 20. So ERC 20 was created for the Ethereum network as a way to represent a fungible token. This is where it's going to get messy. Easiest way to think about a fungible token, because I need a third hand really now, is money. So imagine, I do need a third hand, you've got two 1,000 yen notes. Now, I really don't care which one of these I have because they're identical, they're the same. No, I'd rather like to have both, but I can only have one. I actually don't care which one I've got because it's the same. It's the same value and the same function, utility, no matter what. So that's an easy example of a fungible token. But that doesn't work for CryptoKitties, because CryptoKitties by definition are unique. They have different properties. And so the way to think about them is my son loves football cards. So I nicked these on the way out when I was coming over. So they're two cards. They're kind of the same. They look the same. They're kind of roughly the same. They have the same set of properties, but instances with different properties. So Jack is a Man United fan, so we have Paul Popka. He likes that. He loves Paul Popka. Now, I found a Japanese card. So I was struggling going, what am I going to use? So I found Kaneshima. Is it? Kawashima. Kawashima. Tell me he's the Japanese goalkeeper. Yeah, cool. So, obviously very different. If you ask my son which one he wants, he'll want Popka. If I was going to give you a choice, I suspect you'd go for the goalkeeper. But you can see they're not interchangeable. They represent different things. And that's the problem or the issue CryptoKitties had, that ERC20 is generic. So ERC 721 was created, and CryptoKitties was the first usage of that standard. So now what you have is the ability to represent with the non-fungible pretty much anything that's unique and anything in the real world. So for supply chain, aircraft parts, IoT devices, title deeds, anything now could be represented in a common format using ERC 721 on Ethereum. And given with ERC20, 80% of the tokens on Ethereum were ERC20. There's like 60,000 of them. You're probably going to see in the next couple of years the next wave of digital tokens being based on ERC 721. And that's kind of the big innovation for CryptoKitties. They were the driving force around that standard and the first to use it. And just the last thing, because obviously we're wrapping up, they have another website called Crypto Zombies. And it's very good, again, if you're interested in this kind of thing, because it's tutorial based. It will walk you through how to build these digital assets, and at the end of it, you kind of get a free zombie that you can use. So that's me, thank you. Sorry about the tech at the start, but we got there.